Okay, wonderful. Well, hi everyone, and welcome. It's my name is Michael, and it's my pleasure today to be hosting the second English workshop preview session of Digital Futures workshops to 2023. Um, so we have this is the second session today, Monday. We had the first session on Saturday, which is hosted by Lamila, who is part of the English workshops team. And I want to thank Lamila for hosting a wonderful and very, very inspirational session. We had six workshop presentations, and they're already on YouTube, and you can look them up online. I'll come back to it in my introduction. I also would like to thank the team, English workshops team, who's been working very, very hard on this. Virginia, Lamila, as I said, Ipsita, and Gustavo. And I'm also very pleased that Neil is joining us today. Very briefly about myself, I just joined Digital Futures a couple of months ago. I'm Michael. I'm an artist running a studio here in Berlin and in Austria, and I'm also completing a PhD at the City University of Hong Kong right now, School of Creative Media. So I think without further ado, let me share my screen, give you a brief introduction over our project and workshops, and of course, instructors. I want to thank all the instructors also for being here today. We had such high-level submissions that we went through. It was a real pleasure. And we have 7 workshops today that we'll be going through. And I really want to thank you also for coming together in the spirit of research and knowledge production and pedagogy, in the sense of reaching out to parts of the world where that high level of education may not be easily available or affordable. Please, Neil, go ahead.
No, I just wanted to pick up on that, Mikhail, and just echo that. I was at an event on Saturday, an opening of a thing by Benaz Farahi, who's also been contributing to Digital Futures, and some just came up to me out of the blue and just came to thank me for Digital Futures, and I said, well, don't thank me. It's a team effort, and I just want to echo that and thank the team that's been working incredibly hard on this, preparing for this event, and but also to thank the people who are contributing here today, who are contributing workshops. I mean, this is really a team effort. It's a kind of solidarity. It's sharing our passion for architecture. And even though this is actually nominally in the English language, it's actually incredibly universal, the team that we have here today. Extraordinary. There's Vasco in Bangladesh, we have Abu Dhabi, we've got Iran, we've got all over the place. And I think it's in India. It's fantastic to see this kind of a groundswell of passion and interest. And I think this is truly extraordinary. History will look back on this moment when we transformed from a world where we were always grabbing things to being a one of generosity. And I can't thank you all enough. This is completely a team effort, and thank you. And I want to especially thank those who are just joining in a way the first time. People like Selda, who's giving her first ever workshop. It's great to see this new talent emerging. So thank you so much. Thank you.
Thank you, Neil, for those remarks. I'll go ahead and share my screen. Okay, so we just tested. I think it should be fine. Let's see. Okay, so again, welcome to Digital Futures Workshops 2023. I'll give you a brief overview of the timeline. So we have the hybrid workshops coming up at Tongji in China. I think they're actually mostly on site, as far as I understand. Between 22nd of July and 29th of July, we have our online workshops taking place, which are in Portuguese, Spanish, Turkish, English, Arabic, and Farsi. And 29th of July, there is a closing ceremony coming up. Well, I'll be a bit more precise now. Obviously we have a very extensive YouTube repository, so you can see about like 550 videos. It's really, really wonderful, a wonderful archive. And please subscribe, join us there, and also join our Discord server. Okay, a couple of things coming up in the next 2 months, there's doctoral consortium coming up. I think, Neil, the topic is, I think, camouflage revisited. There is the 5th computational design and robotic fabrication conference coming up at Tongji University called Digital Intelligence, wonderful conference. There are, as I said, the Tongji workshops coming up 24th of June till the 1st of July. And we're starting, as I said, on the 22nd of July, the opening ceremony. The workshops taking place within that week between 22nd and 29th, and then there's a closing ceremony. Also, we're going to have exhibitions and events throughout August. I think they will be advertised and announced separately. So this is our schedule. Here you can see we have instructors, as Neil was already mentioning. This is a wonderful international global event. We have instructors from basically all over the world, and this gives you an impression of how far we're sort of able to reach out. And I'm very proud of that. We've already had the Spanish preview event, the first English preview event, Portuguese, Turkish. Today we're having as I said, the second English preview event, and we're going to have Farsi and Arabic still coming up. This is a quick overview of our YouTube channel. As I said, please join us there, subscribe, and everything that's live streamed is online within very shortly, and you're able to access. Also, if you're missing out on something, please look it up there. Okay, very important for participants. We're starting the registration on June 17th. There is no review process, so we encourage you to register early. And we also encourage you, we hope that you make a firm commitment to the workshops or the one workshop you are signing up for. But please register early. The demand is going to be high. We're going to be closing on the 1st of July, and you'll receive instructions after registering. So be prepared for that. Check your email. Everything you need, we'll let you know how it's going to work. But again, keep in mind to register early. Don't wait. Good. So, as I said, today is the second session. We had a really, really wonderful first session. The quality was amazing, was really, really stunning. 6 high quality workshops. And I'm not going to go into that. You can see it on YouTube. It's already online. So if you've missed out on it, please look it up. I think there's one conclusion we came to after discussion, which is that everyone wanted to take all workshops. so I have a feeling that today we might be arriving at something similar, but let's see. Okay, so in a moment I'll give you an overview of the order of presentations. This is the 7 workshops we have today, and I'll be reading them out in the next slide. They're very diverse. Again, we're really impressed with the super high level of quality. So something to look forward to. Okay. First workshop is going to be Melody Yasha, Boer Deng, Chan Chakmak, Joanna Taseva, Initiative 99, design of a 3D printed affordable housing prototype. Wonderful. This is everything. Yeah, every single workshop is so unique in its own right. So I can't wait. Second, Garrett Sutalin-Santo, Paul Sutalin-Santo, Andrew Depew. Performative biopolymer design, working digitally with plant-based biogels. Number 3, Madi Fart, Amit Sattar, Manas Kaksar, Selda Purali. Bio-integrated modular freeform structures, intelligent design. Number 4, Hesham Shaki and Esther Rubio Madronal, Beyond Static, Exploring Machine Learning for Adaptive Geometries and Expandable Structures. Number 5, Amin Adelzadeh, a form-finding method for trivalent polyhedral timber plate structures. Again, Amin is going to be joining us later. I don't know exactly when. We'll see. Number 6, Ashik Manan Waskor and Rashid Hassan, generative form, generative formation. And number 7, Jack Du, creative coding for absolute beginners. Also great, because I think that's going to be a workshop very open to a very, very broad spectrum of fields and participants. All right, so I think I'm almost done here. And stop sharing and quickly give you a brief overview of our website. Let me share again. Yes. Okay, this is my browser window. So here you can see these are the languages. You just make your selection. For instance, here you can go into English. It's pretty self-explanatory. Choose the workshop. There's info on the instructors, the concept, the also what are the learning objective, workshop outcomes, and also requirements on the part of the participants as well. So it's pretty extensive information. Make sure, look it up before you register. We have plenty of material. And any questions, email us, reach out to us. All right, so happy to answer any questions if they come up, especially from YouTube. And I think I'm done here, and I think we can already move on to the first presentation. Melody, are you ready?
I am. Let's get going. All right. Hello, everybody. My name is Melody Ashar. I'm the Vice President of Building Design and Performance at ICON. Myself and my team manage all of architectural project delivery for ICON's work. What we do is we develop large-scale additive manufacturing technologies for both Earth and space at ICON. In this workshop presentation, I'm going to tell you a little bit about the work we're doing, why we've initiated this workshop titled Initiative 99, what it's intended for, and how it is intended to sort of encourage participation within a global competition that we are kicking off, which is all about the design of 3D printed affordable housing prototypes. So at ICON, we've developed a large-scale gantry-style 3D printer, which we are using to deliver projects in multiple sectors, particularly mass market housing, affordable housing, so for communities in need, as well as for the DoD, and also for space applications. This is our system. We've developed, as I said, a gantry-style printer, which we refer to as the Vulcan. And this workshop and Initiative 99, the competition, will be working with participants, or I shouldn't say with participants, we'll be encouraging participants to use the specs of our printer to actually deliver their designs. This is the printer in action. It operates on rails, and it is very quick, and it introduces tremendous economies of scale when you're introducing single-family detached housing for a large-scale community, for example. So for some project examples, currently we're developing a 100-home community with Lennar, which is a production scale home builder. This is a project which is just north of Austin, and we have about 7 printers, 8 printers deployed simultaneously, delivering, again, single-family detached housing within this community. So we're going to encourage participants of the workshop as well as the competition to think about the typology that is best suited for construction with this system, and also how it might introduce benefits for a community in need. So for communities that may not have access to mass market housing, for example, or it may not be affordable. We've also delivered 3D printed communities in areas outside of the United States, in this case in Nacajuca, Mexico, where we delivered a number of homes that survived a major 7.4 magnitude earthquake. And these homes are all still occupied. And we're looking forward to using this workshop as well as the Initiative 99 competition to think about how we can introduce designs in remote areas where communities may not have access to suitable housing. Of course, we're also interested in encouraging how to use 3D printing to its greatest effect in introducing courageously divergent architecture, which in our opinion is the true value add of additive manufacturing, introducing new forms and geometries that would be prohibitively expensive using traditional rectilinear or flat pack materials or means and methods of construction, and thinking about how we can get more creative, more provocative, and more parametrically interesting when it comes to constructing large-scale architectural forms, which we don't have standard fabrication means and methods for. And these are some examples of work that we're developing in-house, which would be of the typology that we would encourage workshop participants to think about. So Initiative 99, I've been mentioning and referring to Initiative 99 a couple times now. What exactly is it, and what are we encouraging workshop participants to do? In this project, it essentially started as a research and development program to design a home that could be printed and finished out for $99,000 or less. This is a price point which we felt has been a staple and really a benchmark for affordable housing within the United States in multiple jurisdictions. And in my opinion, it has not really been pulled off successfully. There are other building typologies and modalities, modular, prefab, it runs the gamut as far as building construction technologies are concerned, and we still have not been able to realize affordable housing at scale using these new ways of thinking and fabricating and building. So we've initiated a global competition to reinvigorate that discussion. And so we've launched this competition, in our opinion, to reshape the course of affordable housing through 3D printing. Now that our technology has matured and we've actually been able to demonstrate that we are executing on a 100 home community, we feel it's the right time to be introducing this technology for communities that need it most. So our goal is to create one of the most important architectural competitions in the world, to inspire and give hope to thousands of people that housing can be affordable, beautiful, resilient, and accessible all over the world. Build a diverse set of homes, showcasing how 3D printing makes affordable communities that once seemed impossible and out of reach suddenly achievable. And finally, we are committed to building multiple competition-winning designs, which is truly the differentiating factor here. We're not just interested in what workshop participants as well as contestants within the competition submit to us as far as their design quality or values. We actually want to construct these designs. So our competition we're using the workshop as a means of encouraging participants to submit directly to the competition, and also to have access to myself as well as Ken Boer and Joanna, who are all within architecture and building performance at ICON. We're receiving entries within 2 categories, a professional category as well as a student category, so they will be judged separately. And we are also attributing a prize purse of a total of $1 million over the course, that should not say 3 phases, I apologize, over the course of 2 phases. And each phase will award a first prize, second prize, runner-up, as well as multiple honorable mentions. So there's lots of opportunity for recognition here. Some of the topics that we'll be covering within the workshop as a way of encouraging participants to think about their submission to the competition, which is essentially what the final project for the workshop will be, is that we'll be thinking about how to design for small spaces, how to optimize the design so that we're introducing multifunctionality, adaptability, but also introducing benefits that come with integrating fixtures and components, as well as let's say outfitting elements within the 3D print itself within a single building envelope. We're also going to be taking a look at advanced wall geometries, textures, patterns, and perforations, and how those can be incorporated for virtually no added time or cost within the scope of the affordable house print. And finally, we'll be introducing printability constraints relative to our gantry-based system with the Vulcan, and showing and demonstrating how essentially we design with this system in our design to build process. The competition website, you can find more information at initiative99.com. And the instructors for the workshop, it's going to be myself, Boer Dang, who's a senior architectural technologist, Ken Kakmak, who's a design technologist, and Joanna Taseva, who's also a design technologist at ICON. The agenda, this will be a 5-day workshop. The first day will be a series of lectures comprising of an introduction to ICON, an introduction to Initiative 99, a lecture on affordable housing, a review of printability constraints. Day 2 will be all about designing for 3D printing. Day 3 will be desk crits office hours. Day 4, desk crits and office hours. And Day 5, we will have workshop presentations, including guest critique from a jury. Some objectives, I realize this is a lot of text to absorb, but essentially, this workshop is a crash course in designing large-scale additive manufacturing structures. We'll be introducing print parameters and constraints of our technology, and in addition to introducing our high-level project delivery process. This workshop is intended to accelerate thinking on affordable housing design, reinvigorate a stagnant discussion on how architecture might enable the rapid deployment of affordable housing solutions. We're going to encourage workshop participants to explore how affordable housing strategies might leverage generative and parametric computational tools to create highly customized and bespoke details without added cost or time from a construction perspective. And we're going to encourage participants to explore how 3D printing enables rapid economies of scale in production home building, making affordable housing solutions more feasible to implement in various jurisdictions. Thank you so much. I encourage you to check out initiative99.com, and we'll be on the line for questions. I think you might be on mute.
Oh, I was muted. I'm sorry. Well, thank you so much, Melody. This was a wonderfully clear and very, very impressive presentation. I think it's such a beautiful idea to integrate the competition into the workshop and extending your guidance to the participants. So this should be a wonderful opportunity. I think you're actually signing off soon, I think, because you have a couple things, I think, otherwise. So I think if anyone has questions, well, ask them now, because we may not get to that at the end. I have one. I think I have one. I mean, actually, I out of many questions, but I just one out of curiosity. When you're saying all over the world, you're saying this technology can basically adapt to whichever climate.
The scope of the competition right now is global. And the idea being that we want to be able to acknowledge and represent needs within affordable housing that are global and not specific to, let's say, our immediate locality, which for us would be Austin, Texas.
Right.
The technology, I wouldn't make a claim right now that it is ready to deploy worldwide, although we are looking at various international destinations over the long term. But the scope of the competition is absolutely global. We're interested in receiving submissions from everywhere. And based off of some of the, let's say, interest that we've received, many countries have already expressed interest in participating. So we're hoping you'll join the workshop and be one of that group of people too.
That's right. No, this is a wonderful opportunity. Really looking forward to it. Do we have any other questions?
And if anything else comes up, Joanna, Boer, and Ken might be available later on as well, but I'm happy
I
to
see.
now too.
Right. Yeah, thank you again, Melody. This was wonderful.
Great. Thanks so much.
Okay. Garrett, do you want to go ahead?
Yeah, hi. Hi to everyone, and thank you for everyone on the Digital Futures team. I'm going to be introducing our workshop. Let me go ahead and just pull this up right now. Let's see. Okay, I'm hoping everyone can see that. Yeah, so my name is Garrett Santo, and I'm pretty much going to be introducing this workshop on behalf of our team, Performative Biopolymer Design, working digitally with plant-based biogels. We are formulating basically this workshop as an introductory step to working with biomaterials for the first time, making them using deposition techniques and 3D printing, and pretty much taking all of the scope of both creating material, creating the tool paths to utilize sort of like pre-existing equipment like 3D printers or robotics with paste extruders to turn those into customized biogel 3D printers. And so I'll be working with the three of us. My partner, Paul Sutherland Santo, and I both own and cooperate our design firm, Sutherland Santo. And then we're excited to be working with our colleague, Andrew Depew, who's a computational designer and basically an academic researcher and a recent graduate from SCIARC's MS of Architectural Technologies program. And so, we have our bios kind of pretty much online already with Digital Futures. Otherwise, you can look at our website and reach out through Instagram if you have any questions about any of our other work. So the schedule, as we see it, is going to cross over from Saturday, July 22nd, and then we'll meet a few times that'll conclude on Saturday, July 29th. Taking place, just to be sure, within the Pacific Daylight Time zone. We'll go into more detail about this, but essentially everything that we have scheduled here is designed to modularly take you through the production of material, working through Grasshopper. We'll offer a support session and then finally end with either 3D print demos and a presentation of work. Now, I think like the subject matter of what we're dealing with is something that's like really close to home for all of us. And essentially it's based off this like really simple idea that we really believe that for designers, there's major opportunity in perceiving biomaterials, not only for its own flexibility in terms of the idea of being able to produce your own materials and then create those sorts of workflows and digital systems to support them, but just the fact that biomaterials offer a path forward to a future where what we produce is more in line with our natural biological processes and ecological systems. So in our mind, the future belongs to bio-based materials. And we think that part of that's because there's not only flexibility from an aesthetic standpoint. This is sort of just a quick image of a library of biomaterials that we've made in the past and that we will be showing how to produce, at least from like a fundamental level, how you could begin researching to create a library of materials yourself. All of these are plant-based and are designed to explore customizable areas of performance like flexibility, elasticity, and rigidity. Now, we've used this in the past and deployed them from a structural standpoint. And we've even been able to alter them to be able to be fully biodegradable and take place and support pre-existing end-of-life designs that mimic like natural systems, like the way that biomaterial is capable of biodegrading and bringing nutrients back from the air into the soil itself. Now, one of the benefits of making your own material is not only will we cover the methods of producing it for extrusion, but also methods of being able to change the form and the way that these materials deploy and handle, allowing hopefully in the future this to be a foundation for further exploration, like a stool that we produced here, using two robotics with a mounted extruder in order to 3D print a biopolymer membrane on top of a multi-material, in this case, ceramic scaffolding system. But in order to get to like complex problems and questions like this and deploy, they require sort of like a basic understanding of how to use the material. And we decided that one of the things that would work really well is actually to take this opportunity in the workshop to condense a workflow that we have been working on for quite a while, both in context of our own studio work, but also within the context of like academic programs, like in this case, SciArc's MS Technologies workshop, where we're able to bioprint using natural colors and different consistencies and different like patterns that were all digitally produced. So essentially, with this in mind, the scope of what we're going to be covering and planning to cover across the few days that we'll be working is everything from making biogel for extrusion purposes, that being like producing this at home using like really readily available materials. And then I'll go into detail about that in a second, but there is a bit of a list of some materials in the event that you choose to want to make the biogels with us at home. And then we'll take that through like the methods or some of the methods that we have for working in Grasshopper to create some of the custom toolpaths to use those biogels, and then exporting that out of Grasshopper into G-code. The purpose being that G-code is one of the, like a really versatile language that can be applied to augment both the pre-existing 3D printer, but also a robotic system. And we're hoping that if anyone happens to have the ability and access to both a paste extruder and a desktop 3D printer or robot, we'll be supporting the ability to use that hardware with our current G-code. However, we're not going to be providing hardware in this workshop. But ultimately, at the very end, you'll be given the full technical workflow for either future exploration, and then hoping that there'll be an opportunity at the end of the workshop that we will do some of the biopolymer print tests in our own studio and live stream it. So I think it's important, like the foundation of what we're trying to do is to expose designers to biomaterials and the methods for using them digitally. That means that our learning objectives include being able to give like an introduction of biomaterials and contemporary workflows. And the percentages that follow each of these line items are give or take kind of like the emphasis that we're going to be putting on over the course of the workshop. So it's about 10% of that. And then we're going to move directly into a demonstration, and that demonstration will include the methods of producing biomaterial at home, as well as like a tutorial that will be provided for anyone who wants to do research later. And then a large chunk of what we're going to be working with is in Grasshopper, and that's going to include the logics behind like how to design for biomaterial toolpaths, like just basic considerations for designing toolpaths in general, as well as support documentation in Rhino and Grasshopper for the methods that we're going to take things like 2D images and translate those into working toolpaths. And then, like I said, export that for different hardware use. Now, some of the things that, you know, those learning objectives are going to include, this isn't exhaustive, but just so you have like an idea, is like this will be in some ways the way that we'll be producing biomaterials. So everything, like I said, the list are all plant-based ingredients. And then we'll review different methods of adding additives in when necessary as a means for changing both the aesthetic from a color standpoint, as well as like performance and its rigidity, texture, and whatnot. But what you see in the video on the right is the end-to-end of sort of what we're going to be teaching. And then we're hoping that with participation at home in terms of the way that you could produce biomaterial in your kitchen, and if we can simulate digitally and then be able to have actual extrusion be done using your own 3D printers. Now, even if it's not possible to like for participants to have access to a 3D printer, there's absolutely no problem. Much of the like material testing that we'll do for that module can also be done with a syringe and by hand. It'll basically will take you through the method of like altering the material, its opacities and its flexibility, and then be able to go through about how to to start testing the concepts of how you would digitally produce a toolpath at home. Anyway, and then this is here prerequisites. We can look at that later because I think we're getting a little lost in time here. But in addition to that, like I wanted to show that the methods of what we're going to be doing in Grasshopper are graphic based. And that means that we're going to be designing not only just like the toolpath from the standpoint of like how to get the machine to move into the toolpath direction we want, but in a way that extrudes material such that a graphic pattern emerges at the end. This is an additional example of some of the simulation that we'll be doing and hopeful outcomes. We'll be looking at creating toolpaths directly from 2D images where we'll be able to feed in black and white images and have that translate to multi-materiality. Here's an example of the 3D print of what you just saw before in printing graded toolpaths where black is one material type and clear is additional, as well as exploring multi-layer toolpathing, and that being a method of like taking Rhino geometry and translating it into planar prints, as well as exploring methods for 3D printing on non-planar toolpaths. In this case, a pre-laid down subsurface that's not flat, and then being able to follow that surface and print on. Now, these skills are going to require a basic knowledge of Rhino 7 and Grasshopper, which is required. We're not requiring any pre-existing knowledge of like working with biomaterials. And also, while it's preferred, it would be great if there are 3D printers and with paste extruders that could be used. But if not, we're going to be doing everything through software interface. And then, like I said, at the very end, one of the things that we're going to be offering is in our last session, selecting some of the material toolpath designs that we've made here and actually printing them on live stream so that participants can at least see some of the designs that are being made printed over video. These are some like possible outcomes of what we're perceiving to be done, as well as the material both deployed wet and then what a multi-material surface could look like when finally finished. Now, I think that it's just worth noting that in our schedule, our plan is to work on this modularly. So basically what will happen is Saturday, we're going to be doing an intro lecture as well as the cooking demonstration of the biomaterial. And then Sunday, July 23rd and Wednesday, July 26th will be focused entirely on just the bioprinting design considerations, working in Grasshopper, and the support session. Finally, Saturday the 29th is when we'll be doing closing remarks, presenting any research that anyone has been able to do at home, showing and reviewing some of the toolpaths as well as printing them in live stream. So I'm hoping that we'll have lots of participants who are eager to work and that we'll be able to share a lot of what we've learned thus far using biomaterials in a digital context, and hope start off a journey for other designers who are interested in exploring these types of more natural customizable biomaterials within their own workflows. So thank you very much.
Thank you so much, Garrett. This was wonderfully clear and another really brilliant workshop that I think is going to be a great opportunity for everyone. Again, there's many interesting questions. I think we can get there at the end. I suppose one thing I was thinking about is, but again, we should touch upon this later on, is that ultimately we may sort of, you think we would, given what you propose here, is that would we arrive at in a sense, a more sort of localized sense of material, or as a sort of like a knowledge of material that is more localized versus we're distributing concrete and glass all over the planet?
That is absolutely, yes, yeah. That's true. And that is something that we'll hope that if people have the basic access to like a kitchen, like a stovetop is really all that's required, and some basic cooking utensils. We're providing both a list of materials that should be able to be purchased in most grocery stores, or at the very least off something like Amazon, let's say, for if you can't access things like starches. However, the way that we're going to be teaching the production of biomaterial is such that later you can substitute those materials that we're providing for just a standardized demonstration with anything that's local, as well as the base material can be altered, adding in local materials for different types of texture. And I think that is fundamentally at the root of why you would produce your own material, not just to use it to produce specific highly tailored applications, but also just such that you're able to take locally and work with that for distributed manufacturing.
Excellent. That's super interesting. Well, thank you so much. I want to quickly remind let me see. I want to quickly remind students, especially on YouTube, that the registration process, the way it works is there is going to be no portfolio review because we're trying to reduce or remove these barriers. So it's first come, first served, but that also implies the responsibility on your part to make up your mind and make a firm commitment to a workshop that you have the knowledge, you have the requirements, and you're committed to joining and participating actively. Okay, so and it starts June 17th. Check our website. Everything should be mentioned there. But any further questions, we're happy to answer. All right, I think we can move on. Thank you so much, Garrett. This was wonderful. Okay, next up is Madi and team, right? Are you ready?
Yes, sure. Thank you, Michael.
Zelda, thank you so much.
Yes. Can you hear me clearly?
We can hear you well, I think. Yes, I can hear you well.
Okay, I'm waiting for panels, and yeah, we are almost there. Yes, sure. So hi everyone, my name is Zelda Preli, and I'm gonna present our workshop for Digital Futures 2023 with my colleagues. We are delighted to join this year's workshops as part of our mission in Ardana Academy to offer open source education for everyone. So this workshop is named Bio-Integrated Modular Freeform Structures Intelligent Design, and will be held from 24 to 28 of July. And the requirement for this workshop is students to be familiar with Grasshopper and Rhino. This workshop is based on research and development of Ardana team and is a continuous stage of 2 previous workshops in 2021 and 22. So in the previous workshop in 2021, named Functional X Paradigms in Design plus Coding in Python, the mainstream was to extract data from Iranian traditional geometry called Giri as an inverted plan image and employ it to a preferred freeform structure. In the next stage, the structural function was optimized by finite element analysis, and the output was an optimized mesh based on a user-selected pattern. In the next workshop in 2022, called Learning X, Bio-Inspired Design plus Machine Learning, the main concept was to apply bio-integrated data to design columns of a freeform structure. In the first phase, students generated base models with L-systems and Karamba analysis. Then they trained the data for the optimum solutions in Jupyter Notebook. At last, the participants utilized the machine learning techniques to generate the most optimum option for columns with defined features. So as a combination of these 2 research workflows and basically, literally the next generation of previous workshops, in this workshop, we derive inspiration from Persian architectural patterns, utilizing them as a primary reference for modularization. In the second stage, we employ natural growth patterns to develop intelligent functional paradigms. So this time, nature will help us as a second layer of our Giri pattern to reach a performative design solution. As a student, you will start with learning about Giri patterns and modularization concepts, followed by nature-inspired approaches. You will get familiar with AI and machine learning through our lectures, and then you have the opportunity to apply this knowledge to scripting your codes in practice. By generating the first version of models based on Iranian patterns and structural analysis, you will proceed with optimization based on natural patterns. There are also several phases that you can bring your ideas and apply them to your project, from freeform scenarios to structural features, and from architectural base patterns to environmental factors for your own optimization of design. Last but not least, you will be a part of the research team to develop codes and algorithms for the next phases of this research design methodology. So all of our workshops are the starting points to recognize talented students and offer them future collaborations. As a live example, you can see me here as a previous student in Digital Future 2022 and today's instructor. So let's go to quickly review the timeline. In the first day of the workshop, which is July 24, we will have a workshop introduction and agenda overview. We will have we will review the background of optimizing construction process through modularization and introduction to Persian architectural patterns and biofunctional paradigms. And then we will have an overview of the workshop and the schedules and expectation of the entire workshop. In the second day, we will have the exploration of Iranian Giric patterns and historical functions, and also analysis of Giric patterns for modularization in freeform structures. Here, students will start with hands-on exercising applying Giric patterns. And we have the Q&A and discussions on Giric patterns in intelligent design. In the third day, we will have the introduction to nature-based design principles and exploring nature growth patterns in design, and some examples of successful nature-inspired designs. At last, we will have practical exercises using Fusarium as a biointelligent material. The next day, we will have introduction to modular design principles, techniques for creating modular elements in architectural design, and some case studies of successful modular design implementations. And finally, we will go for the hands-on exercises for optimizing the modular elements. The last day of workshop, officially day of the workshop, is a step-by-step guide to implementing concepts which we learned throughout these days, and practical demonstration of software tools and techniques. And finally, the design exercise and the project proposal presentation. So we will discuss the future prospects of applications in this day, which is the last day, but also we will have a final day as a presentation, basically final presentation with an external jury. Okay, please meet our team, which we have Mehdi Fard as our mentor, director and founder of Ardana and Integrated Design, Selda Brali, research assistant at Cardiff University and computational design at Ardana, Ahmed Sattar, computational designer, co-founder of Ardana Academy and program director at Integrated Design, and finally Behnaz Khaksar, computational design and university instructor. So as a very quick introduction to Ardana, Ardana is an integrated network of professionals and researchers in AEC technologies. We embrace computational design, algorithmic methods, AI, and machine learning for seamless integration from design to fabrication. With a strong focus on data, we drive innovative in research and problem solving within the AEC industry. Our mission is to bridge the gap between professional and academic environments, actively engaging in both spheres. If you are interested in our team and mission, please follow us in the social media. And we are looking forward to seeing you at the workshop. Thank you so much.
Thank you so much, Selda. This was a beautiful presentation. Really fantastic. Thank you. It's also wonderful to see how sort of specific, I suppose, local cultural elements are making their way into these workshops. So we're using similar tools, but we're sort of still designing or working or thinking in very diverse ways, which I think is also something that's very, very interesting, and something of how we're hoping to connect the globe. Yeah, we can I suppose we can get to questions in the end. I'm very interested also in this notion of intelligence that you raise in your title. So maybe we can at some point, maybe we can also come back to that. And I think it's also really beautiful that you were, if I understood you correctly, you were a student, so to speak, so in quote, last year, and you've moved on to be an instructor. So wonderful. Well, thank you.
Michael,
and
this is our culture at Ardana. We always run these kind of workshops to find talents, and Zelda is one of them.
Right. No, it's a pleasure. We're very, very pleased to have you on board. All right, let me quickly check the. Good. I think yeah, we're doing sort of well in terms of time. Are you Hisham, are you ready to go? We'll move on to your presentation then.
Yeah, definitely, we're good to go. Let me share my screen.
Thank you. Thank you.
Hi, everybody. First of all, thank you very much to Digital Futures for having us today. It's very exciting. We'll be presenting the workshop Beyond Static, Exploring Machine Learning for Adaptive Geometries in Expandable Structures. And this workshop will be delivered by my colleague Hisham and me, Esther. We're both computational design specialists at Grimshaw, at Design Technology. And we, in addition to this, to our role in Grimshaw, we also have experience in teaching or tutoring at universities, like being Hisham, a tutor at the Institute for Advanced Architecture of Catalonia, or me, I'm an associate lecturer at Oxford Brookes University. But also as part of our roles in Grimshaw Design Technology, we hosted other several workshops before, ranging from differential growth structures, fabrication, to data-driven approach for urban design and master planning. So Grimshaw is an architecture firm that has offices all around the world in LA, New York, London and Paris, Dubai, Melbourne, Sydney, and Auckland. And Design Technology is a group inside Grimshaw. It's a very big team that supports design teams, creating computational design workflows, but also within the BIM environment, urban computation, extended reality, and so on. So the workshop that we've proposed for Digital Futures aims to incorporate machine learning within the design process and to utilize it to explore the relationship between geometry, modular networks, and motion. The workshop is structured in 3 days. On the first day, we will have an introduction to generative design system, recursive modeling, and modularity design rules. So we'll mainly focus in the local or small scale in the design of the module itself and how it moves or how it expands. On the second day, we'll be focusing on surface typologies, global design systems, and the assembly rules. So on this second day, we want to look at the global system and how the module that we designed on the first day is going to be assembled, repeated, and combined to create or form a larger structure or network. And on the third day, we'll finally have an introduction to machine learning and how we're going to integrate it within the proposed workflow. So all 3 steps on all 3 days will follow a case study, an example, a hands-on exercise, and we will then expand our participants to, we will give all the files and all the examples so they can edit or modify this module or modify the network to then create their own exploration using the same workflow. With this structure, we want to touch on a wide range of expertise without necessarily going too deep into each of them, as we want to more focus on the concepts and how they can be connected to form or exemplify a design process. We'll be looking at recursive system and at the advantages of using modularity and design rules, These design rules will help the participants also understand how to work with the assemblies themselves. And for the global scale, we will be working with surfaces that help us generate that network that will host the modules. The participants will then gain a deep understanding on vectors because they will be describing the movement or the expansion of these modules. And finally, we will also touch on how machine learning can help us redefine the design process. So as I said, the workshop will start with the definition of a module. So this module has a set of parameters that defines its shape and the way it connects to others, the way it moves or the way it expands. So this gives us a wide range of different options or states that our module can be in. And we can use, for example, machine learning to visualize or display these different options to then help us keep on working with this. And now we'll hand over to my colleague Hesham that will explain further.
Thanks, Esther. So as Esther mentioned, during the workshop, we'll talk about how we can leverage machine learning to enhance the generative design process to create innovative and efficient solutions. And as she presented, the iterative design approach will employ scripts to generate numerous design variations using the predefined constraints and goals. And this usually allow us to explore vast design space and identify opportunities. So now imagine that if you could even improve this process more by leveraging machine learning. And the machine learning algorithm that you are going to use can be trained to, any machine learning model can be trained to recognize patterns, learn from data, and make predictions. And by integrating that into the generative design process, we can enhance our models and enable them to create even better designs. So mainly during our workshop in particular, we'll be using machine learning for two goals. One is enhancing the design explorations, and second is to accelerate the design iterations. And during the workshop, we'll be using Grasshopper to generate the data set and the generative model design space, and Colab notebooks to communicate with the machine learning models, and finally hops inside Grasshopper to integrate that training back into our design loop. In conclusion, incorporating machine learning during our workshop into the generative design process offers tremendous potential for enhancing design exploration, providing real-time feedback and adaptation. So basically, we're aiming to offer a generic workflow that can be incorporated into different applications, whether it's architecture design, product design, or even complex engineering systems. We try to make the presentation very brief. Thanks for listening and looking forward to meet all of the participants soon. Thanks, guys.
Thank you, Esther and Hesham. This was a very, very clear, very nice presentation. Thank you so much. And also, I think what we were hoping, right, in selecting the workshop, and I think what's coming through here is that we were looking at hoping to select a real diversity of specific approaches to design, computational design. This was a really, really nice example, and super, very much looking forward to it.
Thanks, Martin.
Yeah, and we can get to questions later on. I believe that Amin is here now. I can actually see him in the group. Amin, are you here? Are you ready to present?
Hello. Yes. Yeah. Good to see you all.
Excellent. Then we can keep to our schedule. Wonderful. Thanks.
Yeah,
Good to see you. Go ahead.
All right. Let me share my screen. Sorry, just a second. You see my screen, right?
Yes.
All right. I guess I can turn off my camera. Anyway, doesn't matter. Okay. Hello, everyone, and thank you, DigitalFUTURES, for selecting our proposal. And I'm really happy to be here. And my apologies for sending too much emails and asking you about arranging sort of, timetable. So Thank you so much for your cooperation. Our workshop is actually the form finding method for table and polyhedral timber plate structure that I'm gonna instruct it, and of course my colleague would be there as a critic and guest lecturer that I will introduce you. Just to tell you about us, I mean, I don't want to go into details, but we are actually a group of interdisciplinary team of architects, engineers, and let's say computer scientists, etc. You can find many information about us, so I don't want to go take your time about details on it. But anyway, the focus of our research is on robotic fabrication, lightweight timber structures and construction systems, let's say details and so on, anything related to timber, advanced timber structure, you know, and let's say timber industry, all right? So the actually research that was done by our team before was into plated timber structures, and among all timber products, actually the focus was on the CLT. Actually, we can talk about this during the workshop, but anyway, I'm just introducing you to give you just a general idea about what we're going to talk about. So it's plated based structure and made of CLT plates that, of course, you can search about the material. They will give you a general review during the workshop as well. So this workshop is not just about the computation or coding, programming, whatever. All right, we just wanted to give you a sort of view give you sort of insight into the real world of timber construction. So as you see here, this is where all this concepts begins. Actually, the main thinker behind this was Christopher, but I can explain to you. Production of CLT buildings is not really sustainable in terms of producing too much cutouts. So you see windows and doors are, cut in a wall like this, and we have a large amount of costs that are too small to be built, to be actually involved and to be applied in the building construction. So turning this costs, okay, into a segmented structure, whatever it is, doesn't matter if it's shell, if it's flat surface, all right. Anyway, turning all these cuts into a segmented structure with a lot of material, because actually it's getting more and more expensive nowadays. So it would be, I mean, saving too much energy and cost, especially materials, so on. So once we do this, doing this philosophy actually gives us this opportunity to turn the offcuts of the left, the regular building, as you see in the left, right, and turn it into the right without any extra material, right? So this is the philosophy, and but to do this philosophy, we need connectors. Actually, these are two let's say industrial connectors that are available in the industry, in the market, okay? And for the first time, these two were used. You see, it's known as fixed. They were used as a connector for the segment of the structure by Christopher in our project. And this is actually what we were gonna do. So it's all about connectors and plates, CLT plates, segments, offcuts, and turning them into a segmented structure. And to do this, actually, we need actually a model like this. Of course, this is just a geometric model, not data model. There is a difference between these two, of course, but we will talk about this during the workshop. Anyway, but we need something like this, which is derived from the data, okay? And to get that model, we need many other factors like discretization, like distribution of geometry of the plates, segmentation, and of course, planarization, and many other geometric actually constraints here. Like as you see in the title, we are not dealing with quadratic or triangular pattern. The reason is embedded in geometric constraints, and it has to be discussed during the workshop, okay? So this is what we are gonna be aim for during the workshop. We produce a lot of segments with the connectors. So, and with the real actually CNC machine, we can turn all this geometric model and data model into plates like this with a high level of precision, as you see, like this, with a CNC machine, all right? And with the actually connectors that you are modeling, you can build this kind of a structure by year round. So whatever we are teaching is actually can be realized like this. As you see, it's very simple, and it's a first prototype that was done by our group, and yet the process was the same, like exactly whatever you see here. Like here, all right, it shows the fabrication process based on the same data model that we generated, like tool paths. You see exactly, it's similar to the model. So I'm just showing this to give this sort of idea that we are not talking about abstract, concepts. It's not just, it's old, of course, video, but anyway, I hope this one is, yeah. And here you see all this geometries, turn into this real plate. And you see here, Christopher is putting this connectors. And here we have this sort of a structure, very fast, very strong. Yeah. With this product, and of course with this modeling, because this is the first time that this kind of strategy was used for segmenting the structure. And yes, okay. Here you see I'm just showing you the result of such development of idea, how it becomes reality. All right, and you see we have generated the geometries and then plates like this. And then in the real world, you should do this to divide the whole structure into different parts. We help you how to do this during the workshop. It's actually interface between the geometric and real world. So you have to consider many contributing parameters. And then it shows how actually it's constructed, assembled on site. And it's real actually project, because you see it's loaded on site for experimental load tests, verifying the film analysis. So it's a real project, very strong and lightweight, efficient, sustainable, and so on. And this is the final model with the actually, and it's still there. If you guys are in Germany, you can see this. You can just Google it and find the real place and go there and check the structure. It's there, and it won many actually awards, so on. This is important because it shows the whole concept that we were talking about. This is the result of our previous workshop. So you see, it's not by me or by us. It's generated during the workshop, and of course under my actually supervision, something like the mentor circuit. And this is real data, can be constructed into that project with an alternative. It's not code, it's just a script, a very simple script by Grasshopper using actually Kangaroo and Grasshopper. The reason is that we wanted to keep it very simple and show you how through this actually simple script, but complicated, of course, how you can generate this kind of structure, all right? And just, yeah, simplicity is the best I can say. So many students from different levels can actually attend this, and it's going to be a sort of a start for to get some ideas about the timber structures, prefabrication, lightweight structures, and segmented, of course, and geometric constraints, in each steps actually. So it's from the modeling, real project, segmentation, discretization, and so on. So it's like that, and whatever you will actually here it's in this workshop is based on our more than 4 years of experience, personal, actually mine. But Christopher is a long-time researcher in this kind of area, so he is invited actually as a guest speaker in this workshop. It's very interesting. It's going to be very interesting for young generation of architects, designers that they do not know that much technical actually stuff regarding prefabrication. We know a lot about designing, but we don't know that much about realization of such a complex, especially for the freeform that makes a lot of geometric problems. And even Rhino or many plugins that we're going to use, they're not going to work in the real world. So you need customized design process. This is what we are going to talk about. And my colleague Hamed would be there as a critic actually. And yeah, this is all I guess I can talk. And you can find many information about us, about me, just Google search, and about our projects. And if you need any question, you can find me through LinkedIn, Instagram, Gmail, academic email. Anyway, yeah, thank you so much for this opportunity to be here. Actually, it's a great pleasure. It's a great honor. I guess Neil Lynch is also here. I say hi to him. It's a great pleasure to have you all, to see you all here. Thank you so much for your time.
Well, thank you so much. I mean, as you were saying, I believe that this is certainly will be a great opportunity for being either introduced or to advance, let's say, research in terms of the sort of materials and technology that you were proposing. I think this is super interesting. I just one thing. Could you maybe repeat what are, just to make it clear to students or to potential participants, requirements for, just to make it clear for the workshop, whether it's hardware, whether it's software, just repeat it for once, just so it's clear to them.
Yeah. All right. Yeah, I guess now you see again the share screen, right? My screen, right? Okay. In this. Of course, everything, all the details are on your website. Definitely, they can. It's detailed there, so they can. I kindly suggest students to read them all. And but it's not really complicated. Any student of any kind, from bachelor to PhD, I don't know, researchers, like carpenters, anyone who is interested, who are interested in this kind of research line, timber prefabrication, let's say. All right, are invited and are welcome to this workshop. Second is we don't need that much knowledge regarding this area of research. So students with a basic knowledge about design are invited, and also about the software. We need Rhino, of course, Rhino 7, which you can easily actually get it. And of course, you can just send email to and you can get the code from the official actually reference. And inside the Rhino 7, you can find actually Grasshopper also and Kangaroo. So it's all, and we don't need anything else, because we try to make it keep. If you can add thousands of actually plugins. Of course, we introduce other plugins. You can do it very just circumvent all these actually the codes, but as a basic with this, and we need a good computer with accessibility to the internet, camera, maybe my mic is actually must, but camera is perfect. Yeah, that's it.
Thank you.
The rest of the
Thanks so
details
much.
are on the website. I guess they can read it. And
Right. Yeah, it's still good to have it. Just have it, expressed here. But yeah, wonderful. That was totally clear. And it's a very interesting workshop for sure. So, yeah, this is super exciting. Thank you so much.
You're welcome.
Okay. So, good. Then let's move on. We'll next up is Waskor and Rashad from joining us from Bangladesh, and obviously Waskor, I think, is a longtime participant in Digital Futures,
Yeah.
former student of Neil's.
Yeah.
I should let you guys talk actually and just be in the background, but pleasure to have you here and looking forward to your presentation.
Okay.
Yeah,
Rashid,
take it
can
away.
you? Okay, Rashid, can you?
Yeah, I'm sharing.
Okay, thank you so much, Michael. It's a privilege to be here to share our workshop preview with all. I'm Ashik Bhaskar Mannan. Already you have said, previous student of Neil Leach back to 2004-5 in Bauhaus, Dessau, and Rashid Hassan, my colleague from Bangladesh. We are both in teaching professions. So our previous workshop, we have conducted intelligent formation in 2021, and then responsive formation in 2022, where we have tried to discover emerging forms through rhino, grasshopper, and ladybugs. This year, we will try to explore generative formations to dive into the dynamic intersections of artificial intelligence and architectural form generation. So we will start our workshop with theoretical discussion about the hottest topics around the world, how AI might replace human effort in a number of sectors, especially on design profession. So we pick Alan Turing's one insightful comments, this tool will shape our future. We will discuss about those things, and we will discuss why and how tools are matter for chronological development in design advancement and architectural advancement. It would be our first discussion, and then we will introduce the tools and platform we would like to use for pushing the boundaries of creative expression and innovative formations. And then I'm hand over to Rashid Hassan. He will explain all those things in detail.
Thank you very much. So we'll be using these softwares, as well as we'll be using ChatGPT plus Midjourney, Stable Diffusion, Playground AI, Rhino, Grasshopper, and SketchUp. Okay, so the day one will be training ChatGPT to get prompt for Playground AI, and then we'll try to edit the images out from the outcome of the Playground AI, and we'll have some sketches in our hand sketch, and we'll try to develop them in Stable Diffusion and for various irritation, and we'll have different outcomes. In this second day, we'll be talking about more about Midjourney, and we'll generate architectural concept from prompts. And in this case, we'll using ChatGPT as well. Then we'll be using ChatGPT prompt to Midjourney, and from Midjourney we'll have few form and outcomes, and we'll try to maintain we'll try to get consistent result from a single form, and we'll try to get sketches and outcomes from the sketch, and we'll have elevations, sectional perspective, and interior view, exterior view. In the day 3, we'll be using more Rhino. Here also we'll be using ChatGPT to get Python scripts, and we'll try how to get Python. We'll try to how to get Python scripts from ChatGPT, and how can you use it in Grasshopper and get interesting pattern, and we can shorten the long script to a small one by using ChatGPT. The day 4, we'll also be using ChatGPT again. The same thing like Rhino. We'll be using Ruby script for SketchUp to use different commands for architects. the day 5, participant will choose any of the shown technique or a mixture of different techniques, and they will be thinking about their own context and find a interesting form from the generative from AI, from AI. Will have a real image of their own space or place or their context. Then they can have a conceptual sketch. They can generate form through AI different methods they want, as shown, and then they can visualize and have some schematic drawings like plans, sectional perspective or planar view and everything. Then from their inspiration, they can have a model facade. They can model a facade or a pattern. As Dhaka is my city, Dhaka is a very complex organism and simple diverse relationship with consistent changing and never complete. My city pavilion features colorful rickshaw, vehicle, handkerchief, Muslim saris, mosque, river, kite festival, tea stalls, vegetable, etc. So a participant can derive their form from different ideas, and they can try different softwares, and they can try different shown methods, and they can have forms, interesting forms, and find a interesting pattern, and then we can try to model them, and this is how we will complete our workshop. That's it. Thank you. Thank you very much. Thank you, everyone.
Yeah, thank you so much, Rashad, and thank you, Wesker. It was also like a very, very clear and concise presentation, and certainly, I think it's wonderful that you were sort of able to develop or expand this workshop. I see it almost like as a series, right? You were saying it's like one was in 21, 22, and now in 23. So it's like a real interesting time scale that you're covering there. I didn't actually know that was the case, but that's wonderful. Yeah.
Thank you.
Great. Let me see if there's any questions coming up. No. Okay, good. So I think we're doing actually really well in terms of time as well, and still have a group left here. Okay, good. Then we'll move on to the last presentation, which is Jack. Jack, great. Take it away.
Great. Let me try to share my screen. So, hello everybody, I'm Jack. I'm an artist and instructor at NYU Abu Dhabi's Interactive Media Program. First, I just really want to thank everybody at Digital Futures team, especially the English workshop team, for putting all this together and for facilitating all these events. I really appreciate that. And so the workshop I will be teaching is called Creative Coding for Absolute Beginners. So first of all, what is creative coding? I think for different people, there are different definitions of creative coding. And in general, it's usually just writing code to do anything kind of creative. Some may even argue that all kinds of coding are creative. That's totally fine. I think it's really up to the people who practice this to define what they think is creative coding. But to illustrate what I mean or what I do, I'll show you a couple of examples. One of the first example is called Mandarinizer, which is an interactive installation that I did. Essentially, it's like a virtual mirror that shows the person in front of the installation, shows that image in the form of Mandarin Chinese characters. And I actually also, with the same idea, actually also made it into a sort of experimental web app, camera app, where it can take pictures or videos in the form of Chinese characters. I think a lot of what I do is really trying to build tools that help, to help make computational technology more accessible to people, and especially in like creative scenarios for artistic expressions, really trying to democratize computational technology, for creative expression. One other project I did was -E, which is a drawing robot I did when I was studying at NYU Shanghai. This is a robot that takes image as input and then draws it on the floor. It moves around holding a marker, so it creates a kind of ink drawing of whatever reference image you put. Especially, it's good at image references that are more high contrast. So the kind of image it creates is like kind of ambiguous sometimes, which is really a style. If you see my later work, you can see that it's really a recurring theme of my work. So it's in a style where if you look really closely, these are actually fairly large. It's about 1.7 meter by 1.7 meter. So if you are standing right in front of the drawing, it's like quite abstract. You see those random scribbles. But when you step back and look farther away, or if you pull out your phone, try to take a picture, when you have that more smaller image, more condensed image, where that's when a sort of image forms. This, for instance, is a drawing of the WWF logo, Panda logo. And so more recently, what I've been doing is what I call daily sketches. It's very much inspired by a lot of artists in this field, especially Zach Lieberman, who's a co-founder of one of those platforms called Open Frameworks. He started doing daily sketches. I believe it's like in 2016 or even earlier. He's been doing it consistently. I follow him on Instagram. So I really drew a lot of inspiration from that. And so last year I decided that why don't I start doing this every day? I've been doing this every single day for more than a year now. And it's really been an interesting journey. And this is really the kind of stuff that I'll be teaching in this workshop. And I think one thing about doing something consistently every day is really, it pushes you to be creative every day, and it really, really help you to develop certain skills as you do it every day, do it more often. Practice makes perfect. So just to show you a little more about my sketches, I'll play a short video. So if you are interested in learning more about sketches, you can either scan the QR code or go to the my website. And so what did I use to create those sketches? That's that's a library called p5.js. Essentially, it's a JavaScript library that's made specifically for creative coding. So before p5.js and similar platform or libraries existed, it's actually quite complicated to create visuals because computer programming, especially in the early days, is really designed to create for text-based input, especially back in the days when people use command line as the main way to interact with computers. So libraries like p5.js really help like artists and designers, architects to learn to pick up how to utilize this tool, this computational technology for their work. And the reason why I choose p5. So there are a few different platforms. There's p5.js processing, which is by the same processing foundation. And there's also Open Frameworks, which was founded by Zach Lieberman that I mentioned earlier. But why did I choose p5.js? First of all, it's one of the easiest to pick up, in my opinion. And two, because it's live on the web. So you can do everything inside a browser, so it doesn't require any special software. Sometimes software can be complicated to install. So I think as a first creative coding library, this is really a good start. And it really has a whole lot of features that really unlock like a lot of creative possibilities for people like myself. So I've taught creative coding for different kind of groups. I've taught creative coding for children, younger kids, and also for professional like designers, architects, and also creative coding at NYU Abu Dhabi, which is where I'm at right now. And one other thing I started doing is to sharing some of those workshops on YouTube for free, because as I mentioned, I really my research really focusing on trying to make technology available, like computational technology, more available to people, more accessible. So why don't I just put videos for free and for everybody to watch? And so that's why when I learned about Digital Futures, where it says Digital Futures trying to democratize education, so that was like, wow, that's perfect. That's exactly what I want to try to do as well. And I'm really, really happy that I'm being a part of this. And then I'll give you a more sort of overview of the workshop itself. The workshop starts are divided in 5 sections. The first workshop, which I call Let's Start Sketching. Essentially, that's where we're going to learn the fundamentals, the basics of creative coding, and the basics of JavaScript. And in the second workshop, repeat and repeat. That's where we will be learning how to use how to create animations with repetition. So believe it or not, what you're seeing right now is actually purely made from circles. It's just a lot of small and large circles, very, very close to each other with different colors. And then workshop number 3 is beauty of noises. So this is where we will be learn about Perlin noise, which is a algorithm that really helps make animations or color changes more natural, more organic. Before the invention of Perlin noise, a lot of kind of computer simulated graphics are very much machine-like, very sort of rigid. But with this function, it really helps us create natural movements. And then the workshop number 4 is object-oriented creativity. Essentially, we'll be learning this programming concept called object-oriented programming. And more specifically, we would utilize this concept. We would apply this concept in creating like a particle, what's called a particle system. Essentially, it's right now in this example, I'm doing creating like colorful circles. You can use this to simulate water, clouds, and a lot of different things. And then workshop number 5 is virtual reflections. And this is where we will start adding more interaction with the webcam. So essentially similar to my Mandarinizer project, and the sort of the small video that I showed at the very beginning. This is a category of sketches that can be interactive just by moving around in front of a camera, and then we will learn how to manipulate those pixels captured by the camera, and then to generate this kind of interesting and mesmerizing visuals. So workshop requirements, it's pretty much none, but the bare minimum is that you do need to have a computer, and your computer should connect to internet and a web browser, so you can open this website p5.js.org. And also it requires like the basic math knowledge. So as long as addition, multiplication, just the basic math, you should be able to follow along, and be prepared to really follow along and actually write the code yourself, because it's really, for something like coding, it's really impossible to learn to just by watching it. So you really have to open the code editor yourself and type that in there. That's how you can actually learn. And even better, if you can have certain idea, you can try to work on some projects. And to me, that's really the best way to learn. And that's also why I'm doing daily sketches, where I'm really pushing myself to try to do some kind of creative work, coding work, like every single day. And finally, p5.js web editor, that's sort of the main software, the web application that we will be using. All you need to do is sign up for an account so you can save password. So that you can save your sketches on there, and so you don't lose your sketches. And that's pretty much it. If you have any questions, feel free to again scan the QR code or open the link. There's a link to my Instagram. You can ask questions right now on YouTube, or feel free to reach out to me directly via Instagram. Thank you.
Thank you so much, Jack. That was a very, very nice presentation. Very concise as well. Really enjoyed it. And it's a great workshop. It's a great addition to the other workshops. And it's going to be also really useful, I think, as I think we said in the beginning, to a very sort of broad also range of potential participants. Very nice. There's one thing I was going to mention, which I thought was quite which I found quite striking in the description that you gave initially for your workshop, which I think is what you said, roughly speaking, was like to teach students to think computationally. Am I quoting you right there? Yeah. Exactly. Which I think is a very good and very important point, right? To sort of think algorithmically, or to sort of think in terms of implementation, or in terms of formalized language, which I just personally speaking, for me, to do this consciously was something that really changed things and opened up many things in terms of how I work today. So I think this was just something I found quite striking when you mentioned that, and it's maybe an important thing to point out to potential participants. Yeah, great, Jack. Thanks so much. That was a very nice presentation.
Thank you.
All right. Wonderful. Okay, so we're I hope you all can stay for a little bit for some more discussion. If there are any questions, I think there are any questions online on YouTube. I think not right now. I think on YouTube there's more about the technicalities of registering, and but I think we made those fairly clear. Yeah, exactly. Turn all your cameras on if you can, and we'll it was a super enjoyable session. Thank you all so much. And thank you, Virginia and team, for managing everything along the way. And thanks, Neil, for being here.
Yeah, if I could say something, I want to thank all of you for the presentations. I think we have a really great range of workshops here, even if including the ones that were presented a few days ago, also in English. So we've got ones that are really open to beginners and other ones that are definitely more in depth and for people who already have maybe some training and background. And topics being addressed such as AI, coding, biodesign, speculative design, structures. So this is really exciting to see that variety. I think it is going to be a bit of a hard choice on which ones to take. I know I'm interested in taking so many of them, but I think just remember a lot of them will also be recorded and shared on YouTube as well, on the different instructors channels. So if you cannot join a workshop, the timing doesn't work or whatever, you can always try to watch some of those recordings. But yeah, I think this is such an exciting spread. I don't know if any of the instructors also have thoughts or more things they want to add.
Thank you, Virginia. One thing I was going to add, now that you were mentioning speculative design as well, we have like on Saturday, we had, for instance, a workshop that was concerned with a more sort of post-humanist approach to design. And in that case, I think also if there's any, for instance, if there's a workshop that's also, touching upon a more sort of philosophical realm of things. And I suppose if that's the case, and there's any material you can think of that maybe isn't, let's say, especially pertaining to your workshop, but is more like on the periphery, but could be relevant, then that could be, you could extend that to students and suggest any sort of readings that may help, for instance, like just broaden the perspective of the field. And there's one thing I think that just came up in Bhaskar and Rashid's presentation when you say tools matter, right? That's a very interesting statement, and actually maybe reminds us of like let's say someone like McLuhan, who said that we shape our tools and afterwards the tools shape us, which is sort of echoed in the work of Bernard Stiegler, for instance. And that now we're getting into the philosophy of technology, which is very interesting. It's not what you're proposing, right? But it could be, if someone wants to get into that, by all means, take the opportunity of the workshop to also explore things that may sort of pop up on the side. And so I think this is also really great. And now, so seeing this whole network of workshops, yeah, I mean, I guess I want to take all of them. So yeah.
Yeah, maybe we should start thinking about making this network that you and Virginia pointed out. Between all of these workshops, which were really comprehensive, we can cover design, engineering, and fabrication all over with this cohort. And maybe after the workshop, instructor can actually join kind of reunion or something to develop a network behind it.
That's great, Mehdi. Yeah, let's do it. Let's do it. I'm all for it.
Yeah, great. I wanted to add something to this kind of event. The reason that I'm actually here, it goes back to 3 years ago, I guess, when I was presenting something in a young series of Digital Futures, and I like the concept. When I was talking with Sina during that, Sina Mustafa actually, during that presentation mentioned about something regarding like democratization of education and some of our work together, because I was inviting him actually to Iran to give a lecture for our students. This kind of actually events is really interesting in terms of actually opening up actually door to the students that cannot that they don't have enough this kind of opportunity to get involved with cutting edge researchers, what I'm saying. So it's not really easy for them to learn. Of course, I'm this kind of person that strongly believe in self-education, you know, but this is really interesting because I've seen many actually topics here, AI, you know, machine learning. So, and for me, as to my side, my part is really actually important to me that because I'm coming from architectural background, right? And now dealing with technology, exactly in the core, actually in the core of technology, we're researching in the timber structure. And many of my actually background, you know, had this kind of, comes from a dichotomy, you know, between this, yeah, technology and architecture. When you were talking about design, there still is this kind of critique, you know, or let's say guard against technology. But I believe that we are not doing that much different from 60s, from 50s. You know, if you go back to read the history of theory in architecture, in design, in it's all the same. So I guess we should do this, you know, more and more and in more practical way. To my side is like this because we're dealing with practice, right? Whatever. But I guess it's also nice that people, guys, researchers here are doing with AI. It's very nice, but maybe we can also just to flash back to the past and just say that, okay, during the 50s, it was like this. During the 60s, it was like this. And now we're doing this. In my part, it's like this. We can go back to ancient time, right? We're not doing that much, I guess, more specific than them because they were really genius, you know. So I guess it's really important that we understand the value of what it means to use tools, technology, what's the meaning of them, you know, and so on. This is just my comments to this nice lineup of researchers here.
You're absolutely right. 7,000 years of experience working on architecture stuff from mankind, millions years of experiences in nature. We have a lot to learn. And, you know, putting some bridge between the technology that we have at the moment to those awesome experiences and, of course, resources, by the way, I think it's going to get us more, you know, reliable approach and more responsible ideas with the problem, the complex problem that we are facing at the moment. You're absolutely right.
Thank you.
Yeah, I mean, very, very good points and very interesting points. Please go ahead. Anyone, did I interrupt someone? I was just going to say, just echoing what you said, is of course when oftentimes I suppose like when we talk about technology, it seems like we're talking about computers and iPhones and something digital, but technology, right, started when someone, you know, took a tree branch or took a stone and that's and you know, figured out how to shape the environment through that. And I think that's what we're looking back towards, a sort of long, and I totally agree, you know, back what happened, you know, in whichever ancient times is something that again, like we're looking at a kind of a co-evolvement of how we're sort of, you know, evolving alongside technology and how that shapes us as humans or as like organisms, and how our culture develops along those lines. So this is something that's very pertinent to my own research, but I think I won't open up that rabbit hole right now. Yeah, we can go on. And the one thing actually, Mehdi, and Zelda, I was really interested. Maybe I'm not sure we should open this up, but since you have this this notion of intelligence in your title, I was just going to quickly come back to that and how you how do you conceive of that? Because it's such a sort of pertinent thing that's ubiquitous right now.
That's a key point about this workshop that I'm really excited about, because you know, formally we use some sort of solid geometry and study the performative actions of those geometry from traditional Iranian architecture. And then we start to think about, okay, there is nature, which is live, and we can rely on that, and how nature respond to different, problems that is growing. Like, we're going to use kind of an algorithm related to Fusarium growth pattern, and we're going to ask this as a representative from nature and that kind of intelligence to follow the force follows on a structure. And in that case, we're trying to compare the geometry-based performative actions and how Fusarium reacts to those force follows on the preformed structures. Comparing these two gives us this idea if the geometry works better than nature or not. This is, really an initiative, and it needs a lot of work, I know, but it's really exciting to get to that point, that if nature gives us a better solution or not.
That's right. Yeah, that's very interesting. That's just, thinking about what we mean when we say intelligence. And I think for me especially, sort of this notion of moving away from this notion that there is some kind of universal intelligence and look at it in a more localized way, and in a more sort of particular way, right? As I think you were in a sense just saying. And also I think recognizing different forms of intelligence that sort of go beyond the human. And I think this is also something very interesting, sort of intelligence in sort of materials and how they respond and how they behave and how they sort of act and have agency in their own right, potentially. All right. Yeah, so much interesting things and topics to cover here. Good. Are there any more questions? Everyone's tired.
Maybe we can start asking ourselves, right?
Yeah, true. Yeah, true. We actually do it every day because we believe in like automation and this kind of stuff, but we are not really automated, believe me. I mean, we had CNC machines from decades ago, but we couldn't handle this data interface to use them in architecture. And just recently we are doing this. I mean, we're not that much actually. We believe that we are very, far ahead, but it's not like that. It's not really easy, even with all this material that we have, all these tools and interfaces. It's still complicated, time-consuming, experiences oriented, and so on. So I guess, yeah, these kind of events that we can, see. For me, it's really interesting to see that different researchers are doing different research trajectory, and it opens up my mind, that how we can use this kind of discipline in that way, or another way. Yeah, it's just my comment.
Yeah, exactly. That's one of the most greatest part of Digital Futures. Every year, I start to review the workshops, the exhibitions, the outputs, and I myself have a plan. After the event, I started to rethink about what I thought before, and generating some new ideas based on everyone's innovative way of problem solving and everything. And this is really the beauty of this event. I really like it.
Yeah, great.
Yeah, thanks, Amin and Mehdi, for your thoughts. Yeah, so we're looking forward to now we've had 7 workshops. Now we had 6 Saturday. This is great. I mean, I think these are wonderful opportunities for people, and obviously for us, very interesting to be sort of coordinating this and to have a sense of making it happen and bringing it out there into the world. So thank you all again for joining us. I have a sense maybe you're all busy, have other things coming up, and maybe we should also bring this to a close at this point. But this was super interesting. Pleasure for me to be hosting this, and thanks again to our wonderful team.
Thank you all.
Neil.
Thank you.
Thanks. Merci.
Thank you.
Thank you.
Take care, everyone.
Thank you.
Oh.
Bye-bye.